Do you think I need the mic?
Yes.
I'm not joking. Can you guys hear me now? It's off. Okay, can you hear me now?
Yes.
Do you want me to shout? Okay. I'll try to be sweet and smooth and straight to the point. I just want to ask you guys, my name is Sydney, and I'll be taking you guys for chemistry today and tomorrow, okay? So I figured that if we start today, we need to do acids and bases, the equilibrium stuff. Is that okay? And then tomorrow, we do electrochem, which I feel like everyone finds it difficult. Is that okay? And then organic chemistry. Do you guys have a problem? No. I'm seeing sad faces already. I haven't started. What's wrong? Yes, ma'am? At school as yet. If you haven't done electrochemistry at school as yet, have you done chemical rates then? Then I'll do chemical rates tomorrow with organic chemistry. Have you guys done organic chemistry? Are you guys finding it nice? Oh, okay. So the thing is, guys, listen, I speak very fast generally, so, okay. So if you find out that I'm very fast or you didn't understand anything, please do not hesitate to stop me, okay? Yes, ma'am?
So we haven't covered acids and bases.
At your school? Huh? How many people haven't covered acids and bases? It's only a portion. Okay, so listen to this. It's fine. Listen to this. We're still going to do it, but I'll make sure that the day you go back to school, you understand. I'll be teaching you from scratch, basically, if you don't mind. Because if I try to shift now to something else, some people haven't done it. Is that okay? Is that okay? Yes. Okay, so guys, you need to pay attention. I don't like being disturbed. That's one thing for sure. And then if you want to go to the loo, you just do your thing, okay? Don't just come to me and be like, can I please go to the toilet, okay? You just do your thing and then I'll be happy. Is that okay? So as I was saying, we will start with acids and bases. Before we get started, I want to ask you guys something. What is a base? What is an acid? All right, so there's this thing called an acid, there's this thing called a base. An acid donates what? It donates this. Please guys, make sure that you do understand that. What is now a base? A base, what does it do? It accepts protons. Is that okay? It accepts the same thing. You need to remember that. Such that bases or acids are divided into two. There's these ones that we call them strong acids. Is that okay? There's this one that we call what? Strong bases. So you really need to differentiate between the two. What is a strong acid? A strong acid dissociates completely in a solution or in water. Same applies to a strong base. It disassociates completely in a solution. You need to really remember that. So a strong base dissociates completely, a strong acid dissociates completely. Yes, ma'am?
It's not ionized. Yeah.
Dissociation or ionize is the same thing. Or it ionizes. These are many terms that you can use. In case you find dissociation or it ionizes, please don't kill me, it's the same thing. A strong acid, I will use this one called HCl. Do you guys know hydrochloric acid, yes or no? So HCl plus water. What will happen is we use one-headed arrow there. I'm going to ask the guys that have done this at school. Why do we use one-headed arrow? Why don't we use a double-headed arrow? Because it's strong, so it does it one way. Think of a one-way road. So a strong acid or a strong base, you're seeing it by a one-headed arrow, meaning it's going one direction. So if this guy here is an acid, you expect this water here to act as a base because water is amphiprotic. It means it can either act as a base or as an acid. Are we guys together on that? So what will happen is this acid will donate its protons to the base. If it donates there, you will have Cl minus this side plus H3O plus on the product side. Do we all understand what I just did? And then please don't forget one thing. We call this a conjugate base of the acid. We call this acid a conjugate acid of the base. Do you guys understand? So this is a conjugate acid-base pair. You will learn that when you get to first year. But for now, you just need to know that an acid changes from being an acid to a conjugate base, and then a base changes from being a base to a conjugate acid. I didn't lose anyone from that? Yes or no? I didn't lose anyone? And then it comes to what we call now, and so the one definition you can ever use is, if you get confused, you can always say HA plus H2O. What is it going to give you? You're going to have A minus plus H3O plus. I want you guys to please pay attention. If you started with an acid this side, what you have to get this side is the hydronium ions, which we normally define them as a base. Are we together on that? And then if this was a base, for example, I'm going to say B, which is a base, plus H2O. Remember, what will happen is the base will accept proton from the water that is acting as an acid now. What are you going to have? You're going to have BH plus OH minus. So the point was to understand the fact that if you start with the base this side, you have to have OH minus on the product side. Are we fine? Please make sure that you understand those. And then they require you guys to know a few acids and bases, the strong ones, because everything remains what? Weak. What example would you guys give me of a strong acid? Can I take this out? Are you guys sorted? Can I take it out? Okay, so one example that you guys can give me, or that I will require that you know, is HCl. You need to know that this is a strong acid. Is that okay? You need to know HNO3. Which one is this acid, guy? Nitric acid, yes or no? And then you also need to know H2SO4. What is the name of this acid? Sulfuric acid. You guys please know them. And then also there's this one called hydroiodide or HBr. These are all your strong acids. I'm not going to talk about the hypochlorite because it's part of your scope. So you shouldn't stress up around that one, okay? So please make sure that you are able to give a few examples of your strong acids that dissociate or ionizes completely in solutions. Is that okay? Same applies to the bases. The bases, you need to know that you have got KOH, it's a strong acid. Sodium hydroxide is also a strong acid. And then barium hydroxide is also a strong base. Did I say acid? I was supposed to say base. If I may ask you a very, very, very important question from you guys, what do you guys know about, how did we come about barium hydroxide? Why do I put a 2 in there? Why do I put a 2 in there? Because barium is found in group number, and then an OH is OH minus. So how do you form a compound? You will say, I have barium plus 2, I have OH minus. Do you guys know that the superscripts become what? Subscripts when you form a compound. Do you guys remember that? So when you form this, you will say barium OH2. This 2 is the 2 that was here before. There is a one that I don't really have to write here. You guys please remember your polyatomic ions. How do you form ions? Do you guys understand what I just said? Same applies to group 3. Is that okay? Same applies to group 1. Don't forget group 3, there's this guy called aluminium, right? So if you've got Al is +3, hydroxide is this guy. Remember that? So if you have to write a chemical formula for this one, what or how is it going to look like? You say AlOH3. Is that okay? I'm not losing anyone? Am I losing you guys? No. So you guys are very good to go. So you need to be able to calculate what we call a pH. Do you guys want to volunteer to me and tell me what is pH? How do you calculate pH from an acid or a base? So pay attention to the fact that pH is calculated by saying minus log of H3O plus or of H plus. Do you guys understand this definition? You say minus log into the calculator, and then this means the concentration of the hydronium ions or of the protons. That gives you what? pH. The pH scales run from 1 to what, guys? 1 to? If now I'm less than 7, am I basic or am I acidic? If I'm above 7, am I basic or acidic? Please know that. Is that okay? Are we fine? Oh, you guys can't see. Thank you very much for that. So please know that pH is calculated by minus log hydronium ions or the H plus. This is the same thing. I don't want you guys to get confused. It's the same thing. So pH is minus log concentration of the hydronium ions. That's how you find pH. So it must range from 1 to 14. Are we fine? So if you have a base, they tell you this is a base, calculate the pH. Already at the back of your mind, you know that I expect my pH to be above what? Because it's a base. Are we fine? All right, now let's move on. Are you guys aware of this equation that says pH plus POH is equals to 14? Has any one of you seen an equation like this before? If none of you have seen this equation before, I will only stick to saying pH is equals to minus log of the H plus or of the H3O plus. So we don't have to really go deep into the other things that I feel like you guys should know. Okay, so now let me ask you guys a question. You do have sodium, or you have HCl. HCl looks like this. You've got HCl, it has a concentration of 0.123 molarity. Calculate the pH of the solution. What is the first thing that you have to do? Is to find the concentration of the H plus there. Is that okay? Do you guys understand that the concentration of the H plus there is the same concentration of the HCl minus? Okay, so the concentration of HC of this is equals to this, which is also equals to Cl minus. I want to make sure that you guys understand this because of 1:1 stoichiometric what? Ratio. So per 1 mole of HCl, you have got 1 mole of H plus. Per 1 mole of HCl, you have got 1 mole of Cl minus. That means the concentration of H here is 0.123. Is that okay? So how do you then calculate pH from there? You simply say pH is calculated by saying minus log of the H plus, which is equals to minus log of 0.123. You close your bracket, you press your calculator, you find your answer. Can you guys do it? What is the pH of this solution? Hello, what is the pH of this solution? Ladies and gents, is what? 0.91. So the pH there is 0.91. Is equals to 0.91. 91. So you can approximate it and say it is equals to 1. Is that okay? It's a strong acid. You expect it to be what? To be very, very strong, because HCl is a strong acid. Are we together on that? Please guys, make sure. So let me give you one example of a weak acid. Do you guys know vinegar? Do you guys know that is a weak acid? Alright, so because the definition says a strong acid ionizes fully or dissociates fully, but for a weak acid it does the opposite. It does not dissociate fully. Is that okay? So what we have is, I need to make sure that you guys can see, you have CH3COOH, is that okay? Plus H2O. Right now we use a double-headed arrow because it's not a strong acid. It means it can go back and forth because it's a weak acid. So we use an equilibrium thingy that will happen in there. So we say you have got CH3COO minus plus, what did I say? If you start with an acid, you're going to get this side. You're going to get what? H3O plus, like that. All I wanted you to realize is this. This acid did not ionize completely in the solution. Hence, we say it's a weak acid. Yes, ma'am?
CH3COO minus.
It's minus there. Did I say plus? It's my ghost. It's not me. Okay. Someone wrote that, not me. All right. So basically, all you need to know is you have CH3COOH plus H2O. What you get is CH3COO minus, guys, I made a huge mistake there, plus H3O plus. And then if you try to remember what I said last time, this is an acid. This water is acting as a base. Do you guys see that? And then this is a conjugate what, guys? Base. This is a conjugate what? Acid. Do you guys know what we call a monoprotic acid or a diprotic acid? So you still need to remember the fact that a monoprotic acid is an acid that has got only one H, a diprotic has got 2, and triprotic has got 3. A monoprotic acid, an example is this one, because it has mono means one, mono acid. And then you have got H2SO4, it's a diprotic acid, and then you have got H3CO. CO what? CO3 minus 2. This one is supposed to be H2CO3. There's this another one called phosphoric acid. Do you guys know phosphoric acid? So phosphoric acid is H3PO4. What I wanted you to know is this is a triprotic acid, this is a diprotic acid, this is a monoprotic acid. With monoprotic acid and diprotic acid, they can act as a base or an acid, depending on where you put it to. Let's look at an example for that before we can start answering the questions, because we need to be able to work. I'm just here to refresh your theory right now, okay? This is me trying to be sweet with you and being slow with everything and anything. So if you look at this, if you have H2SO4 plus H2O, what are you going to get this side? You're going to have HSO4 minus plus H3O plus. Do you guys understand this right now, right? And then how about if it now tries to lose the second H? This is equation number 1. Equation number 2, we can say you have got HSO4 minus plus water. So right now, as I was saying, it can depend if this water is a base or an acid. Like at this point, this can either make SO4 minus 2 or it can form back the what? The H2SO4. Do you guys understand what I'm saying? So let's say, I'm going to come back to you now. Let's say the water now is acting as an acid. Is that okay? I'm going to write another one where the water is acting as a base, okay? So that I can answer the question that you have there. How about when you've got HSO4 minus plus H2O that is now acting as a base? Is that okay? So when the water is acting as an acid, it will mean the water will donate it here. Do you guys understand that? If it donates there, what are you guys going to get? You will get your H2SO4 plus OH minus. Do you guys understand that? But if the water is acting as a base, what's going to happen? It will accept this H from this, so that we have got SO4 minus 2 plus OH minus. So please be able to understand that water can act as a base or as an acid.
And the second one is H3O.
Sorry?
The water acts as a base, giving you SO4 minus 2, not OH minus, but H3O.
So check this out. So if this water is acting as a base, what does it do? Oops. My bad. My bad. So this one donated and became that. So it will accept.
It becomes H3O plus.
So what are you going to have this side? Oh, you still have the SO4 minus 2, right?
Yeah.
Plus H3O plus. My bad. Remember, yes, that's correct. My bad there. That was a huge mistake. Guys, please just know how this thing works and you should be fine. So now, with the question paper that I gave you guys, let's start on acids and bases. There's a question paper that I have that I gave you. Let's start answering questions using the little knowledge that we just gained now and see how far we can get. Okay. Try to learn, because learning is very important. So if you look into the first question here, for acids and bases, it looks like this. Okay? It says nitric acid, right, is important in the industry and it is a strong acid. Okay? Okay. And then write down, give a reason why nitric acid is classified as a strong acid. Do you guys want to then tell me why are we saying that? I said, what is the definition of a strong acid? It does what? So that's the first answer that you need to write there. Okay, so, excuse me, can I take all of these out? So we say nitric acid is a strong acid because it ionizes or dissociates completely in solution. You have that one mark, okay? And then the next question says, write down the name of the formula or the conjugate base of nitric acid. Do you guys want to attempt doing that? Of course you can, because all you will then do, you will say you have got HNO3 plus H2O. Is that okay? It's a strong acid, so you write one-headed arrow. Remember, you say I'm going to get here, if this is an acid, that means this water is acting as a base. So you will have what? NO3 minus plus what? H3O plus. Once you have it looking like this, I did say this is a conjugate base of the acid, this is a conjugate acid of the base. So what did the question want again? Conjugate what? What is the formula of the conjugate base? It is what? NO3 minus. You simply move from there. I think you had a question. Is your question answered?
So you said, why can we consider water a base or an acid?
Because water is amphiprotic. It can either act as a base or as an acid depending on where you exposed the water to. So if water is in an environment of a base, it means water will act as an acid. But if water is in an environment of an acid, it means water will act as a base. It can take whatever that you expose to. So in this case, look at it, the water is acting as a base because you have an acid. You can't have acid-acid. It's amphiprotic. That's what we always say. Are you sorted now? Yes, all right. Questions? We're still good. Yes, ma'am? Yes, sir?
What's the name of the conjugated base? So what do we call it?
They said they write down the name or the formula. This is the formula, and then the name is a nitrate ion. Because that is a nitrate ion. Do you guys remember that? Please, you need to know your ions. Yes, ma'am? Okay. Am I too quick? I did say I speak fast, so if you feel like I'm too quick, slow me down. Thank you for reminding me that. So, as I was saying, this is an acid, and then an acid will react with water. That water can act as a base or an acid. Do you remember what I said? And then now you will get a conjugate base of the acid, and then this base will change from being a base to a conjugate acid of whatever that was a base. Did I make myself clear on that? Imagine if now this was not nitric acid, it was sodium hydroxide. Let's see what would happen. Is that okay? So if this was sodium hydroxide, what you will have is, you will say NaOH plus H2O. Remember, it's one-headed out there. So remember one thing, the water here, to answer your question, this is known as a base. This water here will act now as a what? As an acid. Do you understand that? If it acts as an acid there, what are you going to get? That side, you will have OH minus, is that okay? Is that okay? Plus what? What are you then guys going to get? Does it really exist, this equation? I don't think it does. All you can do is, I will write it normally and say if you have a base plus this, plus H2O, what are you guys going to get? If it's one-headed arrow like this, you'll have this plus H2O. That is if that's what they're asking. But all you needed to learn here is that water can act as an acid and water can act as a base, because water is amphiprotic.
So when you're dissociating a base, is the water not brought up with the arrow? And then you separate the ions?
You can, I just don't want to complicate it because it's not part of your scope. Yes, sir?
So the first equation, can't there be an NaH2O?
Which one?
The one where you said it doesn't exist.
What do you think? So you're arguing about the products?
Yes.
So what products do you think I can form here?
NaH2O, so I'm asking if that's possible.
NaH2O?
Yes.
Let me write it for you. You're saying Na. No, don't write it like that, okay? Don't ever do that. Yeah, so some of the things that I will explain here, I feel like it will be big for you, so let me rather not. Shh. Okay, but let's continue with the equation, the question paper, guys. That's what we are here to do, is to learn how to answer questions. Shh. The next question reads as follows. 1.1.3. Calculate the pH of a 0.13 nitric acid solution. Do you see it's worth how many marks? Remember I said to you, you simply say pH is given by minus log of H plus, or you can say of H3O plus. Is that okay? So do you guys see that you have nitric acid there? It has got the concentration. Do you guys see that? Are you with me? Yes. So what do you have to do there? You simply say pH is equals to minus log of what? 0.3. Is that okay? Molarity. Big M means mole per dm cubed. And then you close your bracket, and then since this is an acid, if I may ask you, what pH do you expect? You expect it to be less than what? What is the answer that you guys get when you press this? 0. What? You have your final answer. 3 marks for free. Do you guys understand this? I have a very beautiful question that I want to ask. What if it was H2SO4? how do you calculate a pH of this if you have the same concentration? This is when we take it up a little bit. H2SO4, remember I said it's the concentration of what? The H plus. Do you guys see now that H plus is 2 per 1 mole of H2SO4? Do you guys see that? That means you need to multiply the 0.3 by what? Do you understand? So it becomes 0.6. Yes or no? So all you then do, you will say now, the pH is equals to minus log 0.3 times 2. Then you find your pH from that. Looking into the formula of the acid that is given. If it was phosphoric acid, because there are 3 H's in phosphoric acid, you multiply it by how many? Are you fine? Are you? I'm getting it now. Because we're looking into the H, 1 H, not. You understand? We're looking at it per H. Is the concentration of the H plus or of the H3O plus. 100%? Good stuff. And then the next question comes as follows. It says, how does it read? It says, a laboratory technician wants to determine the percentage purity of magnesium oxide. He dissolves 4.5 grams of the sample of magnesium oxide in 100 centimeter cubic of hydrochloric acid that has got a concentration of that. Okay, and then they say now calculate the number of moles of hydrochloric acid added to the magnesium hydroxide. Let me let you guys attempt it quickly. What do you guys think you need to do there? Do you guys know this formula that says C is equals to N over V? So you need to say C is equals to N over V. This C simply means what? Concentration. Do you guys remember that? And then the N is the number of what? This is now what we call what? Moles. And then the V is equals to what, guys? The volume. In dm cubed. By saying dm cubed, I mean 1 dm cubed is equals to 1 liter. So from now onwards, when you go to the shop, you're buying 1 liter of something, you can defend and say, give me 1 dm cube of that. They'll be like, what? You say, yeah, 1 liter. You move on, okay? So please do not ever forget this conversion factor. It's extremely important. Just like saying 1 cm cubed is equals to 1 what? Milliliter. Please don't forget that. I know for a fact you know that 1 liter is equals to 100 milliliter, what, centimeters. Do you guys know that, right? You know for a fact that 1 meter is equals to 100 what? Centimeter. A meter stick, guys, it's 100 centimeters there. That makes it 1 meter. So there are conversion factors that you guys need to remember off by head, and this is one of them. All right. Okay, now let's move on. The question there says, calculate the number of moles of the HCl that is added to the solution. Remember what I said? I said C is equals to N over V. I wanted to explain something before I even did that. I said C is equals to N over V. Don't forget one thing. The unit of concentration, guys, is always given in moles per liter or per dm cubed. So all I wanted you to learn is we always say it's moles per dm cubed or per liter. So all the time it's always C is equals to N over V. Please pay attention to the units. In this case, they just want you to calculate what? The number of moles of the HCl there. If you are given that C is equals to N over V, basically all you then need to do is to simply say, therefore, N is equals to C multiplied by V. Is that okay? So how do you calculate that, guys, if you look at it? So according to the question, it is 2 dm cubed, and then the volume is 100. So all you need to do is to say this is 2, it's dm cubed, right? Mole per dm cubed. You say mole per dm cubed times the volume. The volume is 100 centimeter cubic. If you convert that into dm cubed, what does it become? 0.1 dm cubed, yes or no? So you say this is going to be 0.1 dm cubed. According to your maths, this dm cubed can cancel this dm cubed. Do you guys remember that? Because they are multiplying, and then the number of moles that you will get there is equals to 2 times 0.1, which is equals to, guys, 0.2. What are these? Moles. Then you are very done.
Can you keep it as moles?
What did the question want? Yes, they wanted the number of moles. So you can say number of moles, 0.2 moles of HCl, to be very clear about what is happening there. Are you guys following? Can I let you guys attempt doing the 1.2.2? So they say here, he then uses the apparatus below to show the titration, the titrant, the excess hydrochloric acid in the above solution against sodium hydroxide solution. Shh. You have got a retort stand, and then they say write down the name of the apparatus Q as shown above. What is the name? What is the name of the apparatus Q as shown above? If you look at it, guys, we call apparatus Q what? A burette. Do you guys know that? It's a burette. Apparatus Q is a burette because this is where you will pour your something, then you open this tab, and then you keep on shaking it until there's color change. What do we call that color change, if I may ask you? End point. What does the end point really say about the solution? So if you have got sodium hydroxide here, and this is HCl, you need to add what we call an indicator. The indicator will show you that you have reached your end point. So the question that I'm asking you now, what is the significance of an end point? Or rather, what does an end point really mean? Think science. You are adding some moles to some moles, and then there's color change. An endpoint simply means the number of moles of whatever that was inside the laminar flask and the number of moles with whatever you are adding are now equal. Please write that down. That's why you have the indicator to show you that you used so much of the base to get an equal amount in terms of moles of the acid and the base. We call it an end point. Sometimes they call it equivalence point. I don't want you to think about equivalence point because this is when you do first year next year. Okay? It's an end point or equivalence point. Yes, ma'am? Okay, I will write it down. So, it is called an end point. Is that okay? This is where you see a what? A color change. You can also say it's called an equivalent point. Is that okay? It means the number of moles of whatever that was on that laminar flask are now equal to the number of moles of whatever you're adding to it. Is that okay? That's why you get a color change. You actually have to see a color change according to the pHs. Remember that? And then what do you guys normally get when you have an acid reacting with a base? It's called what, that reaction? A neutralization what? Reaction. So what do you guys get when you react those two as a product? You get a salt plus, I'm disappointed in you. You get what? A salt plus, please, that you should take to your grave. You must know that. Even on your sleep. When you react HCl plus sodium hydroxide, you get what we call sodium chloride plus what? Plus water. You have to know that. It doesn't change because it's like this forever, okay? Till they add more reactions, but this, they expect you to know. So this is an acid-base reaction. Do you guys see that? Before you even start answering more questions, you can see that, oh, this is an acid-base reaction, so I do expect to form a salt plus water on my product. So, but they've been asking you many questions. So now let's move on and continue with the question. They say now the following indicators were available for the titration. Okay, pick one indicator, either A, B, or C. Which one would you choose, guys? Out of these three, because don't forget one thing, it is called a neutralization reaction. That means a neutralization reaction at pH 7, both the acid and the base have been used up. That means that is when you will see what? A color change. pH what? So choose that indicator according to that table there. Is it A or B or C? Are we fine, guys? The answer that you need to choose there is B. Why B? Because this is a neutralization reaction. You're reacting an acid with a base, so there will be a neutralization process that happens in there such that you will have what? pH 7. So the indicator must be around or must be in a range of pH 7. In this case, it is number B. So you come back there, you say the answer there is B. Okay, which one of the indicators, as I was saying, you say it's number B because it's a neutralization reaction, and the neutralization reaction, the color change will be seen at pH 7. Is that okay? Someone is sleeping. Someone, I didn't mention names. Okay, so are we guys fine? And then now let's move on to the next one. They say here, during the titration, the technician uses distilled water to wash down the solution of the hydroxide spilled against the side of the aluminum flask. Right? Give reasons why the addition of distilled water to the aluminum flask will not influence the results. Have you guys done an experiment like this at school? Yes. Why do we use distilled water in science? Because it does not influence what? The concentration, or you can say it does not influence what? The moles. Please write that down. You will meet that even probably on this exam. We use distilled water because distilled water does not do what? Does not influence the concentration, or the concentration remains constant. You can never use tap water in the lab. You use tap water to only wash what? The equipment, not on experiments, okay? All right. All right, the next question then comes and say, at the end point of the titration, he finds that 21 centimeter cube of a 0.2 sodium solution has been neutralized. The excess HCl neutralized the excess HCl, cool. Calculate the number of moles of the hydrochloric acid that is in excess. First of all, think about writing a chemical balanced equation. Are we together on that? Can you write it down for me, guys? I think I did write it for you. Do you see that I just did it now? No. So let's think about writing a chemical equation in there. How do we write a chemical equation that is happening between a base and an acid? You remember that I said you really need to know that if you write a base and an acid, you get what? Salt plus? Write that equation for me and balance it. Include the states. Good question. By saying states, I mean include the fact that it's aqueous, solid, liquid, or gas. If something is solid, we say it's a precipitate. Do you guys remember that? Can you write it down for me? Write the chemical balanced equation for this. I'm giving you a minute to do that. Just 1 minute. It's something that I just did, and I just took out the paper now. Do you guys remember that? I did now. So all you need to do there is simple. You do this. You say sodium hydroxide, which is aqueous, plus, what was it that was there? HCl, right? HCl, which is aqueous, goes to sodium chloride plus H2O, which is a liquid. This one is also aqueous, not unless you do what we call crystallization, meaning you dissolve all the water. It will then become what now? Salt again. You can experiment with that experiment at home. Take a small pan, take all the salt that you have, put it in a pan, it dissolves, right? And then evaporate the water, you'll have your salt back, right? So don't say it's a solid because it doesn't form a precipitate. It's a solid when you've crystallized this. Do you guys understand what I'm saying? So this is aqueous because if you dissolve it again in water, it donates what? Itself, meaning the water can conduct electricity. Because something that has got AQ, guys, it means once you dissolve it in water, the water is capable of conducting electricity. Do you guys understand that? We call it what, in other words? The one that you know from school. What do we call things that has got aqueous? Electrolytes. Do you guys remember that? We call them electrolytes. Please, it's those definitions that you miss in the books, and they have a very big impact into your life. Okay, so we call this electrolyte because if you dissolve it in water, the water is capable of conducting electricity. It's an electrolyte. So we write AQ, and this is the chemical equation that you need to remember. So also check this out. This equation, do you think it needs to be balanced? Yes or no? So this equation does not need to be balanced. Let's read what the question needs now. The question says the endpoint is found to be 21 centimeter cubic of the sodium hydroxide, and it has neutralized the excess hydrochloric acid. Calculate the number of moles of the hydrochloric acid in excess. Looking into the fact that this is 1:1, do you guys understand that? If you know the number of moles of the hydroxide, do you guys know that you already know the number of moles of what? The HCl, because of 1:1 stoichiometric what? Factor. Can you guys do that for me quickly? Start from an equation that says C is equals to N all over V, and then you will be able to unlock this question. I find it not difficult. Do you understand that? So all you then need to do there is very, very simple. I need to unit here. So basically, you will say now, the number of moles are given by C times V. What is the C that is given there? Do you guys understand that it's 0.2 mole per dm cube? Yes or no? 0.2 what? Mole per dm cubed. Don't forget, you can say per liter if you want to. Multiply it with 0.21. Is that okay? 0.021 dm cubed. Don't forget that 21 is in centimeter cube. You need to work in what? Dm cubed. Yes or no? So what do you guys then do there? You say this is equals to 0.021. What is this? Dm cubed. And then how do you proceed from there? You say this cancels that, and then the answer that you're gonna get is moles. Is that okay? And then the answer that you get there is moles. That will eventually look like 4.21 times 10 to the negative what? 3. These are equals to the moles of sodium hydroxide. But the question wanted the moles of the HCl. Therefore, you come back. Therefore, number of moles of the HCl is equals to 4.21 times 10 to the negative 3. Why? If you motivate, you say 1:1. That's how you give the answer. Because the number of moles of the acid of the base is now known, that means the number of moles of the base is also known, of the acid is also known because of 1:1. Where do I get the 1:1? I'm getting the 1:1 here because the balancing factors, guys, the balancing factors. But if there was a 2 here, if I may ask you guys, if there was a 2 here, what was I supposed to do? Multiplied by 2. Do you understand how you do it? Yes or no? Yes. Thank you very, very much. I think we haven't yet done something hard. Okay. You have to subtract. Are we guys talking about that? You have to subtract. Which one do you then subtract? The actual moles of what? Of the HCl. Do we have any moles of HCl given in here? We don't have. So the number of moles that reacted are equal to the number of moles that are left in excess because it's 1:1 stoichiometric fact. Do you guys understand that? It's 1:1. Whatever that reacted is whatever that is left because of 1:1 stoichiometric fact. Okay? Please pay attention to that. The next question reads as follows. The balanced equation for the reaction between hydrochloric acid and magnesium hydroxide is given as below. Calculate the purity of the magnesium hydroxide. Assume that only magnesium oxide is 4.5 of the solution that reacted. What do you guys need to do if you have to calculate percentage purity using mass? That means you need the mass that reacted divided by the mass original times by 100%. Can you guys attempt doing that quickly? I'm giving you a second. So all we have here, guys, look at this. We have got magnesium hydroxide, magnesium oxide. I'm not supposed to put the bracket there. Let me just be a very good person. Magnesium oxide. Why magnesium oxide written like this? Because oxygen is -2. Do you guys remember that? And then magnesium is group number. So the superscript cancels. Do you guys see that? So that's why it's 1:1. And then you add it to what? To HCl to 2HCl. What do we guys get in the product there? You get magnesium chloride, yes or no? Magnesium chloride, don't forget, this is the salt plus what, guys? Plus the water, yes or no? Yes, so we have it, and fortunately this equation was given to us. So, and this is already balanced. Don't ever believe you when they say it's a balanced equation. Try and figure out if it really is balanced, okay? Sometimes it's a trick. They say, consider this equation, and then that time it's not balanced. Do you guys see that? All right, so they say now, calculate the percentage purity of the magnesium hydroxide. Is that okay? So we need to calculate how much magnesium do we have using the HCl. What are the moles of the HCl, guys? Do you guys see that the moles of the HCl is 0.2? That's when it connects, because the other one wasn't. Okay, so all you then need to do this, you simply say number of moles of HCl, is that okay? Is equals to 0.2 minus the ones that are in excess will give you the number of moles that what remain in solution. Shh. Do you guys remember that? And then you come back, you say the number of moles is equals to 0.2. What was the moles that was in excess last time? It was 4.21, which is now minus 4.21 times 10 to the negative 3. And then the answer that you get there is equals to 0.196 moles. So now you do have the number of moles here, which is equals to 0.196. We can use the stoichiometric factor to find the number of moles of these. Okay? So how do we then do that? We do that by simply saying number of moles of MgO is 2 HCl. I will take it very back to the basic. It's 2:1. Why are we saying 2:1? Because there's a 2 here, there is a 1 that you can see there. And then if we have the number of moles of the HCl given to 0.196, how about the moles of the magnesium hydroxide? You do what here? You cross multi? I think everyone knows how to cross multiply at this point. How do you then cross multiply this thing? You simply come and say the x, which is what I'm looking for, I need to write with a bigger pen, is given by 2x is given by 1 times 0.196, and then you solve for x there. X means you divide this by 2, you will find out your x is equals to 9.8 times 10 to the power negative 2. What are these now, guys? Moles of MgO. If you have the moles of MgO using your periodic table, you know the molar mass. Are we all together? If you have the molar mass and the moles, you know what? The mass that reacted. So, yes, the mass pure, which is the mass that reacted. Yes, so after you have that, you come back, you then say, number of moles is given by mass all over molar mass, which is given by, because you're looking for mass, right? You have the number of moles as this. Shh. You then say 9.8 times 10 to the negative 2 moles is given by the mass divided by 40 grams per mole. This is the molar mass. And then if you want to continue solving for the mass, you say mass is equals to, guys, what are they looking for? The mass. Then you multiply the 2, remember that? And then you multiply the 2, and then you find the answer as 3.92. What are these? Grams pure, which is what reacted. But the question didn't want that, they wanted the mass purity. That means you need to take this 3.92, divide with the 4.5, you multiply that by 100, you find your final answer. Are we together? Okay, so now, in order for you to proceed with this question, you come back, you say, therefore, the percentage purity is given by 3.92 divided by 4.5 times by 100%, and the final answer you get there, 87.11%. It's not difficult. What's difficult is a mindset that tries not to learn. Let's do question number 2, and then we can then change chapters.